The ARM CoreSight technology can be used to continuously collect runtime information for software that runs on Cortex-M-based chips. This video summarizes the real-time trace possibilities for ARM Cortex-M processors. Please note that not all trace sources and sinks described in this video are implemented by all Cortex-M-based chips. Trace information about the program flow is generated for Cortex-M cores by the Embedded Trace Macro Cell, ETM. Please note that the ETM is not available on the Cortex-M0, M0 Plus, and M1. Moreover, not all chips based on other Cortex-M cores implement the ETM. The Data Watch Point and Trace Unit, DWT, allows generating data trace information for a limited number of variables, runtime information on interrupt entries and exits, and performance information such as the interrupt overhead or the sleep cycles. The trace information generated by the Data Watch Point and Trace Unit is sent over the Instrumentation Trace Macro Cell, ITM, to the trace sink. The CoreSight Instrumentation Trace Macro Cell, ITM, additionally enables real-time instrumentation of software, with nearly no impact on system behavior or performance. It requires a modification of the target source code in order to send information to the trace sink. The information generated by the different trace sources is merged into a single trace stream and sent to the trace sinks. We'll mainly talk about two types of trace sinks, on-chip and off-chip trace. For on-chip trace, the trace data is stored in a dedicated on-chip memory or redirected to a system memory. A debugger, such as Trace32, can then read the trace information, accessing the memory over JTAG or serial wire debug. When off-chip trace is used, the trace information is sent to an external trace tool, such as Trace32 MicroTrace, via the Traceport Interface Unit, TPIU. The trace data is exported by the TPIU over 1 to 4 parallel trace data lines. The ITM can also export its trace information over a serial wire output, SWO pin, to a Trace32 trace or debug tool. In this case, the 2-pin debug interface serial wire debug, SWD, is mandatory. Now we know what type of trace information can be generated by the ARM CoreSight trace technology. Program flow information generated by the Embedded Trace Macro Cell. Data trace information generated by the Data Watch Point and Trace Unit. Interrupt entry and exit information generated by the DWT. Performance counter information generated by the DWT. Trace information generated by software instrumentation. We also got to know all types of trace sinks. On-chip trace. Parallel off-chip trace over the TPIU. ITM trace via single-pin SWO. Lauterbach offers the appropriate trace probes to record the generated trace information for all types of trace sinks. Through its comprehensive evaluations, it provides detailed insights into the runtime behavior of Cortex-A and R-based embedded design, such as OS-aware tracing, condition decision coverage, modified condition decision coverage, and more. Runtime details on cores, functions, interrupts. Variable graphical evaluations of the system behavior. Thank you for watching.